Alright, in this lesson we will graph hyperbolas. And let's review what we've done so far. We've looked at circles, and a circle is all the points that are equidistant from the center. They all have every point has the same radius. In the parabola, we saw that every point on the parabola is equidistant from the focus and the directrix. So this distance d1 is equal to d1 here. This is d2 and that's d2. In the ellipse, we saw that every point on the ellipse is, we take the distance from each focus and subtract that, and each of those differences, each of those sums is equal. So d1 plus d2, d3 plus d4 is always going to be the same. And with hyperbolas, that's what the hyperbola looks like. These are vertices and these are foci. And here's how it is defined. If we just look at one side of the hyperbola, right here we have the right branch. And now we'll look at, still looking at a point on the hyperbola and the distance to a focus and the other distance to the focus. So here we have two distances. And in the hyperbola, it's going to be d1 minus d2 is always the same. The difference of these two distances will be the same for every point on the hyperbola. So here we have d3 minus d4. And we can, if we take this distance and rotate it, and we take this distance and rotate it there, we can see how this distance looks pretty close to that distance. And that's what we mean by the differences being equal. And we also have an example of an ellipse. And here we have, if we change it to subtraction, or if it were subtraction, then that's a hyperbola. And this is horizontal, transverse axis. And we can just see by the which variable comes first. The horizontal variable comes first, x comes first, so it's a horizontal transverse axis. If it were switched, that's a hyperbola, but it has a vertical transverse axis. And transverse axis just means which way it's going to open. So this will open vertically and this will open horizontally. Alright, so just like with the ellipse, this the square root of 4 is the distance from center to vertex, horizontal distance. And the 9, if we did square root of 9, that will be the vertical distance from center to Um, conjugate axis. So it's really, there's some new words here, but it's really simple. Here's what it looks like. Oh, we also have c squared. The distance to the foci is a squared plus b squared. With an ellipse, that was a minus. So now we have a plus. And in this case, it doesn't matter which one is a or b because we're adding, so the order doesn't matter. We can just put it like that. This is a squared, and that's b squared. That'll be 13, so c is radical 13. All right. Here we have no horizontal translation, no vertical translation, so the center is at the origin. And we're going to go square root of 4, or 2, horizontally from the center. Then we're going to move 3 vertically since the x is first, we know it's opening horizontally, and that means the graph is going to be opening like this. Before we do that, this is an easy way to draw the asymptotes. And so at this point all the hard work is done, and then we just have to draw the hyperbola approaching the asymptotes. Okay, we talked about the transverse axis. If x is first, then we have a horizontal transverse axis. I mentioned conjugate axis. And c is radical 13. That's the distance to the foci from the center. And this is between 3 and 4. So we're just going to move 1, 2, 3, a little bit beyond 3. Focus. 1, 2, 3, a little bit beyond 3. There's another focus. So that's a vertex, focus, and one more thing we can do, a quick way to find the equations of the asymptotes. And it's just like using the point slope formula. y minus y1 equals m x minus x1. So all we do to make this equation is we replace the y minus y1 with whatever we see up here. This is y minus 0. So maybe to put it in this form, I'd write y minus 0. And then we copy the x's from here, x minus 0. And then we'll have a positive or a negative slope, because we do have two asymptotes. We have a positive slope and a negative slope. And to get the slope, we use the rise over run, which is the vertical distance. We take the vertical distance from the denominator of the y and the horizontal distance from the denominator of the x. So we're going to get 3 over 2. for the slope, and that'll be y equals positive 3 over 2x, y equals negative 3 over 2x, and now we have the two asymptotes. Alright, pause the video and try that one. We know it's going to open horizontally, and we're going to move 4 away from the center. We're going to move 5 vertically away from the center. And that will give us a rectangle that helps us draw the asymptotes. And we know that the hyperbola does not go through this point because x was first. It does go through this point because x was first. It opens horizontally. And we can find the distance to the foci. And that will be between 6 and 7. 1, 2, 3, 4, 5, 6, 7. Somewhere out there is a focus. And we have 4, 5, 6, 7. And there's a focus out there. So we can say that the vertices are at 1, 2, 3, 4, negative 4 and positive 4. Positive or negative 4, comma 0. Foci are at positive or negative radical 41, comma 0, because we go out radical 41 to get to the focus. Let's look at the asymptotes. All we have to do is fill in the point slope formula with whatever we have in the y for the numerator, y minus 0. So we'll just put y, positive or negative slope, and x minus 0, because we get that from the numerator. The slope will be rise, which is 5, over run, which is 4, 5 over 4. And we have two asymptotes. Okay, pause the video and try that one. Here it's going to open vertically, and we're going to move 5 vertically. We're going to move 3 horizontally. And we know it's opening vertically, so that we're going to draw the hyperbola there. And we can find the distance to the foci. That's a squared plus b squared, 25 plus 9 square root square root of 34, so that's almost 6. 1, 2, 3, 4, 5, 6, almost 6. And we can find the asymptotes just by copying the numerators. Y minus y equals x minus x, and rise 5, run 2. Asymptotes. The vertices are 0, 1, 2, 3, 4, 5, 0, positive or negative 5. Foci are 0, positive or negative radical 34. And now we just have to pay attention to the translations. So the center will go down 1 and right 2. Then we follow the same steps where we're going to move vertically 2 spaces, a distance of 2. We'll move horizontally a distance of 4. 1, 2, 3, 4. And it's going to open vertically with foci to radical 5, and that will be between 4 and 5. 1, 2, 3, 4, 5. So we're going to move a little beyond 4 away from the center. 1, 2, 3, 4, and 1, 2, 3, 4. Alright, foci, asymptotes. We just copy the y numerator. Y plus 1 equals positive or negative. Let's copy the x. X minus 2. And the slope will be 2 over 4. Right, and the vertices. Vertices are 2, 1, and 2, negative 1. Nope. 2, 1, 2, 3, negative 3. The foci are 2, and it's going to be negative 1 plus 2 radical 5. Because we go to 2, negative 1, and then up 2 radical 5, and then we go down 2 radical 5, over to 2, to -1 minus 2 radical 5. Pause the video and try that one. We're going to move right 3 and up 1. From that point, we're going to move horizontally 3 and back there. We're going to move vertically 5. And it opens horizontally because X is first. With foci at radical 34, which is almost 6. And that means we have to move 1, 2, 3, 4, 5, 6, almost 6 to get to the focus. And 1, 2, 3, 4, 5, 6 to get the other focus. So we have foci are at 3 over 3. And then we're going to go plus radical 34, 3 plus radical 34, comma 1, and 3 minus radical 34, comma 1, because we're going to be starting here at 3, moving over radical 34, and then the other way, radical 34, with a y value of 1. And the vertices are at 1, 2, 3, 4, 5, 6, 6, 1, and 0, 1. And the asymptotes are y minus 1, x minus 3, and then we find the slope using 5 over 3. Alright, and then we'll just finish up with writing it in standard form before graphing. So before we complete the square, here, we have to factor that out. Since I have a 27, already have a number on the right, I could either subtract numbers here or add numbers there. It'll be the same. So now we want to do half of that squared is 9. I write a 9 on the left, so I'll write a 9 on the right. Half of 2 squared is 1, but it has a value of -4 because we multiply by -4. So by writing a 1, I decrease the left side by 4, so I have to decrease the right side by 4. And all of this adds to 32. So we're going to then have to divide by 32. And to graph that, to help us graph, radical 32 is approximately 5.5. Radical 8 is approximately 2.8. We can use that on the graph. Alright, we have to move to the right 3, down 1. For the center, and then we're going to move 5.5 horizontally. 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5. And we will move vertically 2.8. 1, 2.8. It's opening horizontally, and we'll have this. And we have foci will be at 3 plus radical 40, comma 1. Let's make sure that's right. We're going to go, oh, I didn't do the, find c is c squared equals 32 plus 8, radical 40. So here we have over 3 plus radical 40 minus 1, over 3 minus radical 40. Alright, and vertices. Vertices here, so we're going to be at 3, or we can just, 3 plus radical 32, 3 minus radical 32, and we should probably reduce that to 2 radical 10, and this will be 3 minus 2 radical 10. Down here, radical 32 is 4 radical 2, 3 plus 4 radical 2, 3 minus 4 radical 2. Alright, and we'll stop there.